Okay, these are the video notes for pages 18 through 21, lesson 3. First of all, the first page talks about how a function is created from set A to set B. And then we have in our notes a student class analogy. So I'm going to zoom in on that student class analogy. You can read the first two sentences on your own. And let me go ahead and zoom in on the class analogy. If we map set A to set B, we create a function if for every point in set A, there is exactly one match in set B, or one number that it goes to, only one. All right, so for each x in set A, we're going to go to only one y in set B. However, we might have some other y values in here that aren't belonging to the match, and that's okay. That can happen. We still have a function. All right, well, there are 4 ways we can represent a function. First of all, there's verbally, where we use words to describe a function. For example, for every value for x, there can exist only one y. We can define, or we can represent the function numerically using a table or a map to describe a function. Here we have a table of a function. Every x has only one y. Or we can use a graph to describe a function. Here we have a graph of a parabola. We can also describe a function algebraically, use an equation or a formula to describe a function, such as y equals mx plus b, the equation of a line. Another way to think about a function is any function that can be uniquely solved for y. In other words, any function that is able to be uniquely solved for y where we don't have two values. So what we're going to do here in this equation is we are going to solve for y, and if we get only one value, then it's a function. If we get two values for y, then it's not a function. So we begin solving for y by subtracting 1 from both sides of the equal sign. We get y squared minus x equals a negative 1. Then we add the x, and we get y squared equals x minus 1. And now here's what happens when we take the square root. When we take the square root of this y squared, what ends up happening here on this side is we get y on the left, but on the right we get a plus or minus square root of x minus 1. And because we have this plus or minus value, y can be positive or negative. In this case, we don't have a solution unique for y. So in this case, this particular equation would not be a function. Okay, in the next example, we want to know which of the equations represents y as a function of x. In other words, which one of these two equations is a function? Okay, well, the first thing we need to do is solve for y. So let's go ahead and do that right here. We're going to solve for y by subtracting the x squared from both sides. I'm going to expand this screen so you can see this a little bit better. Okay, here I've subtracted an x squared from both sides of the equal sign. I get y equals negative x squared plus 1. And since we only have one value for y, so y equals only one term, we would say that this is a function. Now let's look at the other example. Example 2, in example 2 we're going to add the x to both sides of the equation, plus x, and we get y squared equals x plus 1. And now we square root both sides, and our final answer is going to be y equals plus or minus the square root of x plus 1. And in this case, we did not get just one value for y, we got two. We got plus root x plus 1 and minus root x plus 1. So because of that, this particular equation is not a function. Okay, in the next example, we are going to find each function value given the value for inside of the function for x. So they give us some values for x that we're going to use. For example, we're going to use a 2, a t, and an x plus 2. So we're going to use those values to substitute into this function right here, and we're going to evaluate it. So I'm going to expand this so you can see it a little better, and we're going to substitute the 2 everywhere there's an x and see what we get. Okay, so we're going to substitute in the 2 everywhere there's an x. So we have negative x. There's our 2 substitution. Plus 4x. There's another 2 substitution. And then plus 1. Well, this equals a negative 4 plus 8 plus 1. Or 5. So when we have x is 2, y is 5. And we can create an ordered pair. Plus 4x plus 1, negative x squared plus 4x plus 1. Now you see for this function, there's no value for x when x is 0. So the function doesn't exist when x is 0. Okay, the next thing we're going to do is find the domain and range of a function. So remember that domain are all the x values and range are all the y values. So when we're trying to find domain, we want to look from left to right along our number line. Okay, from left to right. So let's look at the left of our graph. We're going to look at the left of the graph. How far to the left is this graph going to go? It keeps going down to infinity, so that means that it's going to just keep going. So we've got it coming all the way down to infinity on the left. So the way we write that is we write a D for domain, and then we make an open parentheses that represents the beginning of our domain. And since this function is coming in from negative infinity, we're going to say negative infinity, and then we need to look to see where it stops. Well, it looks like it's stopping right here at -1. See that? Okay, it's stopping here at -1, and that value for x is open. So since it's an open value for 1, we're not going to include 1 in the domain. Then I'm going to use another parentheses instead of a bracket. I would not use a bracket for this particular point because it's not included in our solution, in our domain. So the next thing we're going to do is write our next part of the function, which is this piece right here. This piece here starts at 1. So I would do, this time I would do a union and I would do a bracket. And I would put my 1 comma and look to see where it stopped. Well, it looks like it's stopping right here at where x is 3. That's where it stops. So, and it's an open circle. So again, I'm going to draw my 3, and I'm going to draw parentheses, not a bracket. And the very last piece is this piece right here, this piece of the function. It starts where x is 3, and it goes to infinity. So I'm going to write that just like this. Move this over a little bit. It's a closed 3, it's included, and it goes to infinity. Infinity is always a parenthesis, not a bracket. You put parentheses around infinities. Okay, in the next section we have 4 examples of piecewise functions. I'm going to show you how to do the first one, and then I want you to do the second, third, and fourth one on your own. And I'm going to be checking this in class, so make sure that you give it a try on your own. It's really not hard. We're going to start with the first function, which is right here. This is an absolute value of x plus 1, where x is less than 0. Then we have an x squared, where 0 is less than or equal to x is less than 3. And then we have a 2x plus 1, where x is greater than or equal to 3. All right, so let's start with the first function right here, which is an absolute value function, which we know absolute value functions make a v. This one starts at the y-intercept of 1, so that's where we're going to start our graph. So let's go ahead and draw that line in. Okay, so I've drawn my line in for my absolute value function, and the absolute value function only exists where x is less than 0. So basically all I have is a piece of my absolute value function. That's why these are called piecewise functions. And the piece I have is this left side. Does not include 0, so I have an open circle there. The next function I'm going to do is my quadratic or my parabola. The parabola can only exist between 0 and 3, but not including 3. So the way we draw that is we start here at 0, we draw our parabola, we stop at where x is 3, and we make an open circle. So this part of the function has an open circle at 3 up here at the top of this parabola. The next piece we're going to do is this linear piece, the 2x plus 1. This piece is a little bit trickier to do by hand, but I'm going to go ahead and draw it for you and show you how to do it. Okay, so I've drawn in this linear piece, and this was a little more difficult to do, so I want to show you how I did that. I'm going to go ahead and expand the graph so you can see what I did. I'm going to make it a little bit bigger so you can see. Alright, so what I did was I started my graph. It's 2x plus 1, so I started here at my y-intercept at 1. And I went up 2 over 1, up 2 over 1, up 2 over 1 until I got to the value of x, where x is 3, which is this point right here. I then darkened in my circle because my x is greater than or equal to 3, and then I drew my line up 2 over 1, and that's all I needed to draw my line, and my arrow goes at the top. And that's it. That's how you graph that piecewise function. So you try the next 3 graphs and let me know if you have any questions.